Exploratory Data Analysis, EDA, and Preprocessing. There are various steps in machine learning AI projects which start with data collection followed by EDA and preprocessing. So first step is usually to define the objective, what we are trying to achieve in machine learning or AI project. Then the next step is data collection and overview. We need to look at data and have basic idea about what this data is all about. Then we start with data cleaning, data transformation and feature engineering. After that, usually we do univariate analysis followed by bivariate analysis, then multivariate analysis, some kind of visualization on top of all these analysis to tell the story. Then we apply our domain knowledge and some of the statistical testing like hypothesis testing, probability, all those. Time series analysis. If data has time series element, then those analysis is being performed. Text data analysis. If data has text element or text processing required, like mostly language model, LLM, all these will require huge amount of text analysis and corresponding text data processing. Image data analysis. If the project is about image, then we have to do a lot of analysis on image data and subsequently pre-processing for this data. Then we have to perform data quality checks and any kind of anonymization that may be required. Data suitability assessment. So at this stage, we have collected data, we have gone through various transformation, cleaning, pre-processing, exploration, and we should be able to decide whether this data is fit for purpose and it is meeting the objective or the way we want to use this data for machine learning or AI project. Sometimes we have to do feature importance analysis to keep certain features and discard some of them. Also, it's very important for machine learning and AI project or deep learning project to document all this analysis and do reporting as necessary as per the organizational standards. But these steps are iterative. We have to do it multiple, it has to be repeated after training the model as well. I have created a simple checklist for EDA and pre-processing steps. This can be referred while performing EDA and pre-processing. This has a further breakdown in terms of what activities need to be performed. All the 17 steps that I have gone through earlier, all these are listed here and further minute details. So when I'll be performing EDA or pre-processing with sample datasets or specific project, I'll be using this template as a reference and also putting down all the activities or all the steps that is being performed or action taken. Now I will go through a toy dataset to explain various exploratory data analysis. I won't be covering any pre-processing in this video. This will be exclusively on EDA. Though this is a toy dataset, the concept and ideas can be extended to any machine learning or AI projects in exploring the data, understanding the data, and then deciding how the model or which model need to be used to train. So here I'll be using a toy example dataset called Titanic, which is very popular and well known. I have downloaded it from Kaggle. So here first I am loading required libraries: Pandas, Numpy, Matplotlib, Seaborn for visualization, and sklearn, scikit-learn I'll be using for PCA, SciPy for stats. So first, using Pandas, I'll be loading Titanic dataset, which is kept in my local drive in the same folder as this Jupyter notebook is present. First step is collection data and overview. So here we have collected the data, now need to check what it contains. First, we'll check how many rows and columns are present. So for which we'll be using dot shape with the data frame. So we can see there are 891 rows and 12 columns. Let's take a look at first 5 rows. So we will be using head method from Pandas. And if you can see, these are the various data columns and these are the 5 rows. So we can, it's blank. Like Kevin, it's none, not a number, right? So we'll be handling all this later when we do pre-processing. Again, maybe we can also take a look at the last 5 rows. Now, one of the inbuilt feature, it's called info. So this can be used to understand what are the different types of data available. Here we can see there are total 12 columns or 12 features. Also, it shows how many are non-null. So you can see age has some null data elements. Kevin also has a lot of null data elements. And this column talks about various data types associated with each data element or columns. So we can see in total there are 2 float 64, 5 integer 64, and 5 object, which are basically text or mixed data. Now we can also use inbuilt describe to see various statistics for numerical data. So here, these are the numerical data, and we can see the counts and the mean of the data, standard deviation, minimum values, maximum values, and quantile values. So 25%, 50%, and 75%. At this stage, we have loaded the dataset. We have taken a basic look at how many columns and rows are present, how is the distribution, and how many of them are numeric. All these things we have checked. Next step is data cleaning. First, we'll check how many null values are present. So we'll take the null values and then sum it. As we have seen earlier, age has 177 null values, Kevin has 687, and Bert has 2. We can similarly also use isNA, and it's actually an alias of null. So if I just comment out the previous one and just use NA and rerun, it remains same. So if you look at Pandas documentation, isNA is basically an alias of isNull. Now, many times we need to make some decision what to do with the data, and in those scenarios, it's important that we have some idea about how many of these missings are really relevant, and for this we may want to use percentage. We'll take the percentage of values which are missing. So you see almost 20% of age have missing values, while for Kevin it's like 77% are missing. So during our pre-processing steps, we might want to remove both of them, or we might have to do some special imputation to handle them. Next, we have created few subset of data for further processing. One I have created for numeric using np.number, just included those specific data types. Another one I have created for integer specific columns. Another one is for text columns. All this will be useful later when we do specific handling. Now, next we will be doing outlier checks. There are 2 ways we can check outlier. One is numeric, another is visual graphical. So in this step, numerically, we'll check the z-score and IQR. I'll be using stats z-score to apply for all these numeric columns. Now here for outliers, I am using 3 sigma from z-score. So let's see how many data element comes in. Here it's showing all the outliers detected for all these rows. So you can see 13, 16, these are the rows number where there's the outlier, and it's a large number, right? So we can even further fine tune. Say I am looking for 6 sigma. And we can see if we use 6 sigma, only 4 rows are falling outside as a outlier. Similarly, interquartile range method will tell how many of this data are falling outside of 25% and 75% of data element range. So again, I have created a function where I am using quantile functionality from or quantile method from Pandas directly. I'm applying only for numeric data types. So if you see, after printing the data, we have around 151 rows which are falling outside the 75% and 25% range of the code. So if I change it a little bit, right? Let's make it maybe anything below 5% and anything above 95% is falling into that range. We want to treat them as outlier. Then if you see, we have again 4 as the outlier. So these are like an iterative process, and sometimes we may want to take certain outlier based on specific use cases. Now let's take a look at specific value related inconsistency or specific range related inconsistency. So I have created a function to check a range giving the dataset column name and minimum value and maximum value. It will call out if anything falling outside of this range. So if you see, it is checking if it is less than minimum value or greater than maximum value, then it will return the row. So first I am checking if anyone with the age is in dataset having age as minimum as 0 and maximum as 100. Let's take a look how it looks like. So as you can see, data looks good. Nothing is below 0 or above 100. What about if I change it to say 70? So maximum age is 70. As you can see, there are few records. So this way, if we know something specific to a feature or column that it falls under the specific range or values, then we can set these checks. Similarly for fair, suppose the value is need to be between 0 and 500. If I run it, I can see there are 3 records which are the values are a little bit higher than 500. Again, this is an iterative process. As we have seen, we might have to do a multiple permutation combination to see how the data looks like. Now next, we'll be checking if there is a specific categorical columns and the values are beyond some range. So we have 2 sets where passenger class is 1, 2, 3 and embarked is only CQS. These are the values only allowed. So if anything outside these values, there could be an inconsistency in the data. So let's run it. So you see, I'm checking for the embarked expected values from all these 3 values, and you see these 2 rows are flagged out because they are not a number. So either those values are not captured or there were some error in the data. Also, you want to check if there are unique values in. Usually the ticket numbers will be unique. One person will be assigned one ticket. So you can use Pandas built-in method duplicated to check for tickets if there is any duplicate or not. Wow, there are many duplicates. There are 344 rows which are duplicate. So you see all these 3, 7, 8, all these are duplicate, has duplicate ticket number. So we might have to later check what is the reason behind these duplicate tickets. There may be one family assigned one ticket number. So something like that could be the reason. Now, next thing is usually we may have to ensure that dataset has no duplicate rows. So how do we do it? We'll be running a duplicated functions or method from Pandas library inbuilt function. So if we run that, we see there is no duplicate. So 891 columns for all this, there is no duplicate. So with that, our analysis on data cleaning part is done. After this analysis, usually we will be doing data imputation to correct the missing values. And if there are certain values which are unexpected, so we need to cure them. Either we remove them or replace them with some values. If there are outliers value, we'll have some special treatment to them. So I'll be covering them in their respective videos with more details and more examples from different datasets. Next, we'll take a look at univariate analysis. Next three, univariate, bivariate, and multivariate analysis, all these are graphical visualization to see how the columns and data are spread across or what are the relationship between different columns. All these aspects of data we'll be checking through this analysis. So first, as part of univariate analysis, we'll be doing histograms for numeric columns. So we'll take the numeric columns and basically we'll run one by one. I coded this as a dynamic code. So whatever the numeric columns is, it will use Matplotlib and Seaborn to show the visualization side by side. So let's run it and see. So if you see the distribution of passengers, distribution of survived, there are two values, either survived or not survived. Passenger class, there were 3 classes and you can see the distribution. Sibling of passenger, you see how, so almost 600 don't have any siblings, and some distribution for other categories. Again, distribution for parts. Now, this passenger ID is basically a unique value, right? Each passenger has one ID given in this dataset. So it doesn't really give any additional information in this visualization. Maybe we want to remove it. So one way to remove it is here. Maybe I can use, because these are list, I can use remove. I'll be using the same passenger ID. And let's see. Okay, now passenger ID is removed and all the others we can see. If we want to use count plot, it's the same thing we are using. Only thing is, instead of histogram, we are using count plot. And you see a little bit more colorful, this one, because I changed the palette to bright. So here again, it's showing the survived classes, but all these are shown differently. And maybe here I can remove some of this just to show that since there are too many categories which is coming from passenger ID, let me try to remove it here again and run it once again to just see it. Yeah, much better and very colorful, and we can easily see how different data are distributed and what are the count of each of them. Next, we will run plot for categorical variables. We are running here bar plot for categorical variables, and you again see the name is there, so it's coming like this. Again, the tickets also, there are many tickets variation, but maybe what is more interesting to see the distribution of sex and embarked. So instead of this entire data set, maybe I can just take I remove name, I remove ticket, Kevin also too many, so maybe remove Kevin as well. Just embarked and sex I keep and rerun this. So now you can see the distribution for sex and distribution of embarked. Next we'll be doing bivariate analysis. So in bivariate analysis we'll be doing scatter plot, and we'll be also running correlation between various data element. So again, here I am doing a scatter plot between age and fair, and if you see the correlation matrix, I am running against all the fields. One thing you need to understand that if we just run the correlation directly with this data frame, it won't work. Maybe I can show it. So this is the pair plot between age and fair. So you can see how the distribution is. Now you see the correlation didn't work because it could not convert all the string values. So one way to do it is we can use factorization. So let me comment it, and I can use factorization. I'll use a lambda function to factorize each field and then use correlation on top of it. So let me rerun once again. Now you can see, so there are some strong correlation. The name and passenger ID has a strong correlation, which is understandable. We can see ticket and passenger ID also has a strong correlation. So all this data element, usually in machine learning step, we'll be removing them because these are like a duplicate information, or they may influence the model compared to other fields which are less correlated, right? So there are tests available to see individual field, which one to take, which one not to take. We'll cover them in upcoming lessons. Again, you can see there is negative correlation. Some are negative, minus signs are there. Sex and survived also have positive correlation, which is around 0.54, which is interesting. There are few fields we can see there are no correlation between them, like survived and embarked have no correlation. See, it is 0.1. So this correlation matrix gives us a very good information about the data. This is a box plot that we are doing against age and survived. So you can see there are few elements and how it is spread. Now we'll do multivariate analysis. So multivariate analysis will be using pair plot for age, fair, and survived. I am using hue as survived and palette as bright. Let's see how it looks. So you can see how the data is spread and what is the relation between these values. So fair, age, fair, and survived. So one thing I can do is I can adjust the padding to see is it looking better. Yeah, a little bit gap. You might have to play around with this data multiple times to see how it looks like. I have removed a message because it's using a tight layout from Matplotlib, but you can adjust all this, the look and feel, and also like what kind of palette need to be used. I'll be here using PCA just to see how it is transforming, and you can see the PCA. These are the two principal component. After dimensionality reduction, everything is looking like this. It's not giving much information here, but many data set, PCA gives a very good view of how data is spread. Like there is a data set called MNIST. So after PCA, we can see the clustering of data, like numbers 1, 2, 3, all these are clustered. Many clustering techniques, wherever we use, PCA could have very good insight how the data is spread. We can also use TSNE, LDA, and many other advanced techniques, manifold techniques to see the data. But here I'll just restrict it to PCA. Now, after these three different bivariate, multivariate, and univariate analysis, we'll take a look at domain knowledge and hypothesis testing. Here we'll be just doing a normal test. So if you see the statistic normal test for survived, p-class, sibling, p-arch, all these are the values, and p-value is 0 for all of them. Based on p-value, we can conclude these features are not normally distributed. Also, as we have seen, there is a field called name, which is a PII data. So if we want to anonymize that data, one option could be use hashing. So we can import hash library, and we can encode all the names using hashing. We are using show 256, SHA 256 to encode the data. So let's see how it looks after hashing. So we have created a new column called name underscore hashed. So this is after hashing, the value will change. So let's see how it looks like. So this is the column which hashed value. So all the name fields can be replaced with hashed value. And in the final dataset, we can remove the name and only use name hash as the derived field. That's all for EDA with this dataset. We are not covering many other EDA because it's not relevant to this dataset. But in our future lessons, when all those specific use cases or scenarios we'll be covering, we'll be also showing like text specific, time series specific, or maybe image specific EDA. That's all for this lesson. Thank you so much. In next lesson, we will be focusing on data cleaning. In that lesson, we'll share sample code with various data imputation and handling techniques for missing, outlier, duplicate, and various inconsistent data. Stay tuned for another exciting lesson coming soon.